Alright, so this is a video for solving a system of equations by graphing. As you can see on the screen, we have two equations. That's what a system of equation is. It's just two or more equations on the same graph. In our class, we're only going to worry about two equations. So we need to solve this by graphing. That means we need to graph both of the lines and then see where or if they intersect. So we have two equations here, but we can't graph them yet. Why not? Think about that for a second. What's wrong with these two lines? Why can't we graph them? They're not in slope-intercept form. They need to be in the form of y equals mx plus b. That way, we can look at it, know the slope, know the y-intercept, and graph it. So, in this first equation, this one right over here, 3x plus y equals 10. The y is not by itself. We want to get the y by itself, so I taught you a good graphic organizer back in the day. You can circle the y, or the term that has the y in it, and then get rid of everything else. So that's the 3x. How do you get rid of a positive 3x? You do minus 3x, minus 3x. On the left-hand side, gone. We're left with y equals. On the right-hand side, we have 10 minus 3x. Well, those are not like terms, so I'm just going to leave it. 10 minus 3x. Now we can graph it. We have a y-intercept, that would be right here, and we have our slope. So, I'm going to start on the graph. 1, 2, 3, 4, 5, 6, 7, 10 right there. The y-intercept was 10, that's where I'm starting. The slope is negative 3, so I can rewrite that as negative 3 over 1. Down 3 over 1. Down 3 over 1. Down 3 over 1. At this point, if you're on paper, you have a ruler. You can just use your ruler to extend the line across the entire graph. I do not, so I am going to do my best to just draw a straight line here. That's going to be as close as I'm going to get. I'm going to label my line, because if I do not label my line, I will not know which line I am dealing with, and I will forget. On a smartboard, I have a blue marker and I have a red marker, so I know which line is which, but you don't have that. So this line is 3x plus y equals 10. Notice I write the original equation. Now let's look at the second equation. 2x minus 2y equals 6. Circle the term that has the y in it. Get rid of everything else. We have a positive 2x, so we're going to do minus 2x. Minus 2x. Gone. We're left with a negative 2y equals 6 minus 2x. Divide everything by negative 2. And we're left with y equals 6 divided by negative 2 is a negative 3. Then we have a negative 2 over negative 2, that's a positive 1x, or just x. So y equals negative 3 plus x. Y-intercept of negative 3 goes up 1 over 1 because the slope is 1. And it doesn't look like it's going to intersect at a good point. Alright, well this equation doesn't really work out so well, but we can still see that they will eventually cross. This equation is 2x minus 2y equals 6. They do eventually intersect. They intersect right around here. So that is our solution. Unfortunately, this one didn't really work out so well. But I do want to show you how to check something like this. So let's say that this did work out. Let's say our equations were 3x plus y equals 10. And let's say our other equation was, instead of 6, let's make that so instead of a 6, let's make it a 10. So 2x minus 2y, 10. Alright, that's better. Now, assuming we know how to put these into slope-intercept form, or we know how to graph it, we can see where they intersect. I'm going to tell you, for this problem, the solution is, okay, just kidding, instead of 10, I'm going to make it 12. Again, this isn't really that important. The point of this slide is I'm going to show you how to check your solution. So now I know that the solution is 4, negative 2. You would get that solution by putting this on a graph and seeing where they intersect. So now that we have this, this is where you have to be really careful. We know that in slope-intercept form, this is y equals 10 minus 3x. And this equation over here is y equals negative 6 plus x. But when you substitute your solution back into the equation, you use the original equation. You do not use the slope-intercept form. You always substitute back into the original equation. So I take this solution, 4, which is an x value, negative 2, which is a y value, and I substitute them into the equation. So 3 times 4 plus negative 2 equals 10. 3 times 4 is 12, plus negative 2 is minus 2, equals 10. 12 minus 2 is 10, equals 10. That works. In the other equation, 2 times 4 minus 2 times negative 2 equals 12. 2 times 4 is 8. Minus 2 times negative 2 is a plus 4, equals 12. 8 plus 4 is 12, equals 12. Check. They both work. That means that this point is on both of the lines. That means that it is correct. That is how you do a check. You take the x value and put it where the x goes. You take the y value and put it where the y goes. Let me show you one more really quickly. I'll give you an easier system. We'll say y equals 2x plus 3 and y equals x plus 4. And the solution is 1, 5. So now, the 1 is my x value, the 5 is my y value. I substitute that into both of these equations. 5 equals 2 times 1 plus 3. 5 equals 2 plus 3. 5 equals 5. Check. 5 equals 1 plus 4. 5 equals 5. Check. Works for both of them. That means this is a solution. All right. Do some practice with this. Make sure you know how to put equations into slope-intercept form. Make sure you know how to graph. Remember that negative lines with a negative slope, go down and to the right. A lot of you have been going down and left, which is a positive slope, so be careful about that.